As a person, I'm very interested in personal finance, and this is basically why I also wrote the smart contracts to execute some of the things I love to do, or some of the features in my existing personal finance app that I'm using. And in this contract, I'll be showing you how you can implement time lock in your smart contract, and it is the way that people can deposit money and get to receive it after a defined timeline. In the case of the smart contract, the timeline is 100 days. So people will keep depositing money and they will be able to get them back or get it back after 100 days. This is basically to ensure discipline and ensure that everyone grows in their personal finance and wealth creation journey. Without much ado, I'll be going into the first contract and I'll be showing you how to implement the time lock contract. Initially, I've written an article where I explained everything in this contract. So this is basically a video overview. All right, let's get into this. So as you can see here, we named the contract Smart Contract Money Club. Then this is application admin. Application admin is the deployment address, and it is basically the address of the team behind the application. Then we created a user struct to kind of compress all the basic details we'll need. That's the name of a user or probably a nickname this time around. Then the saving goal and their wallet address. And we use the respective data types for each of this stuff. We will always have to reference this struct at a couple of times. So I created this array called user address array to always reference the user struct all the times or whenever we need to do that. This is the saving span. It is the time where the smart contract will exist for. In the instant case, I plan it to exist for 100 days, meaning people will be able to deposit money for 100 days and get the money back, the money they've saved over the course of these days at the end of the 100 days. So I created this name for block.timestamp. That's the global variable, but for the context of this contract, I named it the beginning. So, and I made everything private. This is the percentage fee. We will use it subsequently, then you get to understand how this works. This is Boo Checkmate. This is basically to checkmate against reentrancy. As we progress in this tutorial, you understand why we, did that. Then here are the mappings. One for users balance, the other for balances map, registered user, registration time, and those are basically the four mappings. And the reason we made this engineering choices, you'll get to know them more when we get into the functions, and I'll also be cross-referencing them so you will know why we are making several or each of these variables or decisions. So I initialized the application admin above to msd.sender. That is when you are deploying. The deployment address will be the application admin. The next stage is the modifiers. We have three modifiers in this contract. The first one is only owner. This helps us to know the contract that only the owners can call. Now, if you don't create these modifiers, we'll have to write several of these checks in each of these contracts. But to write smarter and neater code, we just created this modifiers for convenience. Then this is for only registered users. We made the map so the registered users of msd.sender, we used the mapping above to call this, and it will ensure that only those who have registered will be able to call the contract we had this to. This is checkmate reentrancy. We are trying to block every possibility of an attacker draining our contracts via the withdrawal function. So we are checkmating anyone withdrawing twice while everything is still executing. I think that's pretty much about the state of the contract. Now let's proceed into the functions. This is the join club function. This is the function you have to call when you want to join the money club, where you will be depositing your money for discipline and personal finance. So this is the function you use to join. You have to impute, these are the compulsory parameters: name, saving goal, and user address. You have to impute these three particulars or parameters for you to successfully join the club. And I made the joining to be free. You don't really have to pay to start using the app. The plan is to make it so people can easily use it and no much stress. We included two checks for registered users. You can't register twice with the same name, particular, or address. You only one user registration. Then no address, zero. Definitely this is to checkmate every possibilities of DOS attack. And yeah, at this juncture, this is where the users get to impute their details. If we didn't declare this parameters via the arguments, it will show an error. So we had already declared them locally in the arguments, then the users can really call them. The moment you have registered or a user has registered, the registration will set to true. Recall that default for Boolean data types is false. So in the instant case, we have set it to true. That means that their registration is considered true, approved, or existing. Then the registration time starts, meaning that the moment you register, your 100 days of saving funds starts counting. Then we move on to the next function, which is deposit money. Here we have already added this modifier, only registered users. So only registered users will be able to deposit money to lock in the contract. And of course, anything you want to deposit must not be less than zero. Must not be less than zero. And we made it to increase the value of MSG.value, and that's how everything will keep incrementing with time. The next function is the withdrawal function, and this is only after the 100 days have elapsed. You can't call this contract unless the 100 days have elapsed. This is require the address of whoever is calling this function is greater than 0, definitely. And it must have been only registered user, and we checkmated reentrancy. Then we executed this function call. If you are aware, this is the best way to make a function call as far as Solidity is concerned, and security-wise, it's better. So users can withdraw to a withdrawal destination address. Initially, it could have been designed in such a way that users can withdraw to the address they probably are on, but for better stuff and specificity, it is better for them to impute where they want to withdraw the money they have saved so far. Now, it is the case that real life can be quite funny, so I added a function for urgent withdrawal. That means if you cannot wait till everything, all the 100 days have elapsed, you can definitely withdraw urgently, and that is the essence of this function. As always, only registered users can call it, and we have checkmated against reentrancy. So there is, oh goodness. All right, so for you to really withdraw urgently, you will have to pay a fine of 10%, and that is to ensure that people don't take this function frivolously and they only call it when they can't take it anymore. And this is how we did it. So penalty fee, we assign it to amount to withdraw multiplied by the percentage fee, which is 20% all over 100. If you do the math, it will go well. Then this is the withdrawable amount. This is amount to withdraw minus the penalty fee. We have defined penalty fee here, don't forget. When that is done, we send the penalty fee to the application admin. That's the team behind the contract. Then the users can withdraw to their destination address. This is a function to extend saving period. For instance, a user might want to save for a business, then they might realize that they need to save more. You can definitely extend the time for which you save this way. And how I executed it is that extra time is assigned to span extension multiplied by 30 days. So the number of months you want to extend for, just impute it there. Automatically the contract will multiply by 30 days, and that turns it into equivalent of months. Once that is done, it is added to the timeline, and the extra time becomes part of the user's timeline. Definitely, users should be able to leave the club when they feel like, and that is why I included the leave club function. This way, they can basically delete the address from the contract, and we are sad to see them go. This is another function to know how many users are in the contract. So we use the user address array, then we access its length. That will help us to know the number. So if there are 20 different addresses that are registered for the contract, the dot length will fetch us the number of these addresses. Then, as the admin or the team behind the contract should be able to know how much is in the contract, and this is with the address balance. Users should also be able to know how much they have deposited. Maybe they forget or they want to be sure. Then this function is there, and they can put in their address and get to know how much they have deposited. That's the first contract, basically for savings, time lock, or thrift. The second contract is for spend and save. The idea behind this is that as much as you are spending money, some percentage of the money you are spending is being kept in a separate address, and this is to enhance overall personal finance. So we had to create a separate contract for this to ensure cleanliness. We could have added this to the initial contract, but it will mix up and it will give auditors some time before they even figure out which is which. So it is better to, engineering wise, decision wise, it is better to create new contracts for exactly new features. If you check the states, it's pretty much the same with the other one. Then there are a couple of changes, and that is first, they can set their discipline wallet. So the discipline wallet is where the percentage of the money you want to spend goes into. Then users can deposit money. Of course, this is the kind of function in the initial contract. This is the main function, spend to save. You can spend to save in the contract. And basically, how we got to do that is we created a couple of local variables, remaining money and to be saved. To be saved is amount to withdraw multiplied by percentage to save all over 100. That's what will fetch us how much will be saved in a spending. Then this percentage is sent to the discipline address. The actual purchase is the remaining money. Then you can send the remaining money to the address of where you want to buy things. Really, the idea behind this contract is so people can buy groceries from malls, from supermarkets, and provided the malls or supermarkets have crypto addresses, they can basically buy it from the DApp, and it works pretty much fine. Now that we are done, explaining the contract and how it works, the next step should be to test it. And right now we are in Remix. Indeed, the Remix is not the best to use for smart contract testing because you will miss out on a lot of bugs in terms of performance and even security. But it is the case that I am also learning Remix myself. I'm also learning Foundry myself, so I'm not too good with Foundry yet to write, robust Foundry test. That is why I'll be using Remix to test. But like I said earlier, Remix is not the best place to test your contracts in terms of performance, in terms of security. And as you are aware, the intent behind this whole contract is to eventually deploy it on the Linea blockchain. So right now, I'll be showing you how you can easily deploy this on Linea. But first of all, you have to set up your Linea wallet and get some Linea faucets. You should get the MetaMask extension if you don't. And I encourage you, don't use your actual wallet for this. Create a separate wallet for testing. That's the best move. Then come to your MetaMask. I want to open mine. Okay, it's open. Come under Add Network. Generally, you should be able to find Linea, but you only see Linea mainnet. But we are definitely testing, so it's better to use the Linea Sepolia testnet. As a result of that, you must come to your MetaMask and toggle Show Test Networks. So come here, you will see Linea, Guali, Linea, Sepolia. I prefer Sepolia. I think Guali is already deprecated anyway, so we're using Linea Sepolia. Then click on it. It's this way. I have a few ETH in my Linea. Then the next stuff for you to do is to get faucets to test out this contract. And right now, I'll be showing you how to do that. As a developer, whenever you want to fix anything, the documentation should always be your friend, and it's always my friend. So if you want to get a few faucets, these are a couple of places to get them. You can get them from Infura, from GetBlock, from Covalent, and get some ETH there. Then let's proceed in the actual contracts. Come to deployment, pick MetaMask. It will trigger your screen. Then you will have to maybe input your password or approve the transaction and get things going. So click on next. Permission, permit Remix to access it. Then you are good to go. We are starting with the spend save contract, or let's start with the saving contract for time lock. Let's deploy it. It will take a couple of minutes, as you can see on my screen right now. Confirm the transaction. This is the contract that has been deployed. You can see the hash, the status, timestamp. I just deployed it now. This is the time I deployed the contract. You can see it here. Then the method. Basically, if you're familiar with Block Explorers, you should be able to read what's going on here. Then the transfer fee I spent, the way price, everything, it's all available on chain. If you want to know more details, then you'll see every other thing else you want to see. So our contract is deployed. Let's start testing it. What should be the... Let's check down here. So let's see if we can join the contract. All right. So this is here you impute your name, baptizer, go, gadgets, user address, then transact accordingly. It should trigger your MetaMask. You have to approve the transaction. Then it will go through. We are using faucet, so the we are using faucets, so we might not have luxury of ETH to use for testing. For this reason, I will basically be using more of Way. So let's say we want to deposit 200,000 Way. Let's see if we can do that. I'm trying to be economical with the faucets. Oh, beautiful, we can. All right, this went through. We have deposited some Way here. Well, it is the case that it might not show because it's not up to 1 ETH. Let's proceed and call any function. Okay, let's call urgent withdrawal function, or basically normal withdrawal. So how much do we want to withdraw? We want to withdraw Way to this address. Okay, let's check that went through. So let's see how much is there. I'll check my MetaMask now. Okay, I have 0.0012 ETH. All right, let's move it. So we have withdrawn. Then no total deposited money. This is the total deposited money that my address did. Then you can also check this 2,000. The total number. This is going through because the same address that deployed is the same address that is entering as a user. If I had a couple of Linea addresses with ETH, with Sepolia ETH, I would have used different addresses. But I hope you get out what I'm trying to do. And eventually, I will still give a tutorial of how to do this with Foundry. And I think that's probably the best for you to learn how to do this. Basically, I think that's pretty much. Okay, let's test. Okay, we tested urgent withdrawal. We tested almost every function here. Let's move to the next one. Spend and save. Let's try to deploy it. Oh, I don't have enough gas, but pretty much the same way I deployed the first contract is the same way you deploy this, and you can get to test it for yourself with different addresses and get to see alpha. It seems this is going through, so give me a minute. Oh, beautiful, beautiful, it's going through. Let's delete this contract so we can deploy a new one. All right, so the deployment failed because there was no enough gas. So we can't really test that, but it actually works. I tested it with normal remix ether, outside the network, and it works. So this is basically an issue of faucets. We can try it, and whenever I'm done with the Foundry test, I'll share it all on this YouTube channel so you can get to see how everything works in details, and we can check against several vectors, performance, and every other thing else to be checked. Thank you so much for learning from this contract. I hope you really do. And if you have any question, let me know, and I'll be very much happy to make this clearer to you and help you become a better blockchain developer. If you have not subscribed to this channel, ensure you do, and I will see you in the next. I remain John Fowley.